Hello everyone, welcome back to online survey video tutorial on hydrology and irrigation engineering. So in this class we are continuing with the module 3, that is hydrograph part, and in this class we are covering the concept of unit hydrograph and the assumptions, applications and limitations. So coming to the definition of unit hydrograph, so it is an hydrograph of direct runoff which is resulting from 1 centimeter of effective rainfall which is applied uniformly over the basin area at a uniform rate during a specified period of time. So I'll tell you, so unit hydrograph means when a 1 centimeter of effective rainfall applied on an area, so of a given basin area, uniformly at a uniform rate for a specified period of time, whatever the direct runoff which results from supplying 1 centimeter of rainfall, so that is called the unit hydrograph. So unit hydrograph means it is a hydrograph which represents the direct runoff from a 1 centimeter of effective rainfall for a specified period of time. And here, there are so many assumptions which are very important. So before studying this hydrograph, so it is very important to solve the problems. So, to know what are the assumptions which are made in this unit hydrograph concept. So there are around so many various assumptions. The first assumption is effective rainfall is uniformly distributed within its duration, and also it is uniformly distributed throughout the whole area of the basin. The first assumption is rainfall is uniformly distributed with respect to duration, and the second assumption is it is uniformly distributed with respect to the basin area. And the third one is the base period of direct runoff hydrograph. So due to an effective rainfall of a same duration is constant, that is nothing but the base period for direct runoff hydrograph and the effective rainfall both should be same. So that is the third assumption. So the next assumptions are the ordinates of direct runoff hydrograph of a common base period are directly proportional to the total volume of direct runoff represented by each hydrograph. So where that is called the principle of linearity or the principle of superposition, which is nothing but, see, if you have a n number of hydrographs like this, so the total volume of these number of hydrographs so will be equal to the ordinate of direct runoff hydrograph with a common base period. So that is nothing but the addition of n number of hydrograph will be equal to the single hydrograph, which represent the volumes are equal and the ordinates are equal and with the same base period. The base period is also equal. So that is called the principle of superposition. And the last assumption is for a given drainage basin, the hydrograph of runoff due to a given period of rainfall reflects all the combined physical characteristics of the basin, so which is known as the principle of a time variance. So which is nothing but, so whatever this hydrograph is there, so runoff hydrograph so will vary, so will also represent the basin characteristics, that is basin physical characteristics, so which is known as a principle of time invariance. So those are the assumptions which are made in this unit hydrograph. So the next topic, you have the application of this unit hydrograph. So basically, so this unit hydrographs are used in case of flood hydrograph. Okay, so you can calculate the flood hydrograph easily, so with a very short period of time. So if you have an unit hydrograph, and also, so in addition to the peak flow, unit hydrograph also gives a total volume of runoff and its time distribution. So it will also give, so it not only give the peak flow, okay, it will also give the runoff volume and how the runoff will vary with respect to time. And also the unit hydrograph procedure can be computerized easily to facilitate calculation. So you can easily use a computer to do the calculation, so which is very easier, and also it is very useful in checking the reliability of flows. so which is obtained by using any statistical method. So you have various statistical method, so you can use any of those methods so to check the reliability of the flows. So those are the applications of this unit hydrograph. So coming to the limitations, so you have certain limitations also. See, basically, whatever the assumptions, the first assumption is, the effective rainfall is uniformly distributed over the basin. So that is what the assumption what we have made, but that is not practically true. Okay, so whatever the effective rainfall so is assumed to be uniform, it is not practically true in case of large basin because it is not uniform, it is non-uniform. And also, so this unit hydrograph theory is limited to 6,000 kilometers square. You cannot apply this theory for a basins which is exceeding 6,000 kilometers square. And also, this at that particular case, if the area is more than 6,000 kilometers square, what you are going to do? So we are going to divide the area into n number of areas, and we are going to plot the hydrograph separately for the divided areas, and after that we are going to add it up. So, and also if the precipitation is in the form of snow, you cannot use this unit hydrograph theory. And also, so unit hydrograph which is derived from a very small rainfall limits, so will generally have a lower peak value. So it will be having a lower peak value. So that's why, so you cannot apply this, you cannot use this unit hydrograph theory. So for a large basin. Thank you all. So we'll just continue in the next class.